Hello all, today in this video we are going to work with another deep learning algorithm which is RNN. So in this work we are going to work with Adam optimizer, and the next in future proceeding videos we will be working with different optimizers, and as done in CNN and ANN we will make a comparison of which optimizer is providing the better results. For that, initially we are importing the libraries which we are needed, and then we are importing that, loading the data set. The data set we have used is heart disease data set. This data set we downloaded from Kaggle. You can just give us heart disease detection. Kaggle means you will get this data set. The data set which we have used is having nearly 14 entries. You may notice that it is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last entry, which is the target one, we will be using as the y variable. Then we are getting the info of the data set, whether our data set is having any null values or not. Since and also whether the type of the data set. From that we can get to know that the whole peak is the float type and all others are integers. And then we are also checking whether our null data is having any null values. You can notice that every entries are having 0, that is it is not having any null values. If it is having any null values means we have to work with pre-processing function. Since it is not having any null values, we have omitted this pre-processing. Then we are just displaying the heat map of the data set. So this is the heat map of the data set for heart disease which we are using. Then we are determining the x variable and the y variable. As I said, within the x variable we will omit the target variable, and apart from that every variable will be used as the x variable. When coming to y, only the target variable will be used as the y variable. And here we are, by use of this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. And with the use of the train, test and split function, we are determining variables like x train, x test, y train and y test. Then we are using the use of standard scalar function to convert the variables to vectors for the variables like x train and x test. Then we are getting the shape of the variable. So here we are not using any reshaping, so I will just delete it. Here we are getting the shape of the data set. Why? Because this shape only we will be using here. Sorry, we have to reshape, and that reshape value only we will be using here. By mistake I just deleted it. In the next video we can use it. So that variable we have called over here, and then we have made the layered distribution for the RNN. It consists of the sequential layer followed by the simple RNN layer, a dense layer. A simple RNN layer is calling the input shape and the activation as ReLU. Then within the dense layer we have called the output dimension as 1. Why? Because our work is a binary classification work. So mostly in binary classification work, the number of classes we will determine as 1 only, and the activation we will give a sigmoid. So if it is a multi-class classification means we will just replace this 1 by the number of classes which we are having. Then we are getting the summary of this model, and this is the summary of this model. And then we are compiling this model by using this laws as binary cross entropy, optimizer as Adam, and metrics as accuracy. Then we are getting trained by using the fit function, and by using the variables like x train, y train. Within the validation data we are determining x test and y test and approaches as 50. So nearly for 50 approaches this model works, and you may notice that for every approaches the mod accuracy is increased, and also when compared to validation accuracy is high. Validation accuracy is high, and at the end of 50 approaches we have got nearly 100% accuracy. Then we are declaring an diagram to just plot the values like loss, accuracy, validation loss, and validation accuracy. Here you may notice, by this you may notice that the training accuracy and validation accuracy is more or less overlapping. Initially, training accuracy and validation accuracy is having some merge points, but after some 30th approaches, everything is same only. Training accuracy and validation accuracy both as 100. This applies for both validation loss and training loss also. Then we are defining a classification report, and we have displayed the classification report for every performance metrics parameters like precision, recall, F1 score, and support. We have got the accuracy as 100. Then we are making a definition for the confusion matrix, and as per that we are displaying the confusion matrix, and this is the confusion matrix figure for this Adam optimizer. In the next video we will be working with some other optimizer, and we will make an comparison with the Adam optimizer and that optimizer which we have made. Thank you.